found it funny.
Well, it wasn't wrinkled, it was crinkled.
Well, that's whenever you fix it.
I did fix it. Oh my God. I hate you guys. Okay, so first off, I walked around. Most of you have this done perfectly, but a rectangular array is another way of showing the distributive property. What mathematical operation is the distributive property? Nevaeh, I don't care if you were stretching or not. What mathematical operation is the distributive property? Teach you to stretch in my class. Is it addition, subtraction, multiplication, or division? What do we do in the distributing property? Do we add, do we subtract, do we multiply, do we divide? And I bet there's a chart over there that's kind of showing what we do in the distributive property. One of our anchor charts. I bet your table can help you. We what? We multiply. So, we are actually going to end up multiplying our rectangular array. So, on your sheet you have 3, and I'm going to say this so you guys can start to get the mathematical terminology. I cannot say 3 times 3 plus 2. That is not the same thing as saying it correctly. This is 3 multiplied by the quantity of. When we see parentheses, that's the quantity of. So 3 multiplied by the quantity of 3 plus 2. So the number that I'm distributing is now my width of my rectangle. My lengths, because 3 is bigger than 2, so this portion is going to be bigger. This portion, and I still want to keep the sign with it. It's a positive 2. Okay, still with me? Relatively easy. The second one, all it does is now it's taking the place of that 3 with a variable. Because that's what variables do. They're replacing something that's an unknown. For us, it's really a number. So again, my rectangular array, my width is the number that I'm distributing by. My lengths, I don't know how big x is, so I'm going to make it a lot bigger than the 2. There it is. And then I have my positive 2 here. Questions on how to draw a rectangular array. That's the easy part. What just happened? No SIM card installed. I don't know what that means. I don't know if we've been able to see it. It just popped up that said no SIM card. And I don't. Huh?
It means that you won't be able to text anyone.
That's all right. I don't plan on doing that in the middle of my lesson, I don't think. Good here. So here's what you're doing on your own. So at the bottom of that page, it's talking about distributing. It is saying find the area of each section of that box, I believe. Determine the area of each region using the distributive property. So I want you to find the area of this box. I want you to find the area of this box. This is where I want you talking it over, talking about how we find the area of rectangles, come up with a formula, come up with answers. Go. So I should hear you talking about it.
I would do 16 plus 5. I don't know. Oh, we're doing so no, I have no idea. It's a 5, so you might do 16. But can't we just add 16 plus 5 and then
If you want, you can, like, one of you can move over so you guys can actually talk. You don't have to. It's you.
Okay.
Okay, so first off, it's giving us two rectangles. I'm physically going to break those apart. I don't think any of you did this, but you don't have to. I'm doing this because I'm not very smart and I want to make sure that I know what I'm doing. What is this side of my rectangle?
11.
Braden? 11. What's the bottom of the bigger rectangle?
16.
Braden?
16.
16. What's this side of this small rectangle? Tegan? So what would the number be? 11, very good. And what would the bottom be? Go, Braden. 5. Okay. So really all I've done is I've taken my rectangular array and I've split it into two pieces. We all right with that? It's asking me to find the area. And one of the questions I asked you to do is say, hey, have the area formula. What is the area formula for a rectangle? This is something we should all have. It should be one of those things that we know. It's 2 letters. How do we find the area of a rectangle, Lizzie? Length times width. So, Addie, what 2 numbers am I going to have to multiply here to find my area?
11 times 16.
Good. What 2 numbers am I going to have to multiply here, Brooke? 11 times 5. I will give you 1 more minute. Everybody needs to get these answers now. So I want the area of each individual rectangle. So finish your multiplication. Get me the product. Product, remember, is the answer to a multiplication problem. Okay. Your shoes have this same kind of stuff. How do you keep them clean? Wash them? Okay. So how many did you see on salt and stuff for the syrup? Oh. Yeah, I know. It's ridiculous. Wash it. You put them in the washer? Okay, so Macy, what did we get for the area of this first rectangle?
176.
Okay, so wait. Macy said that this is 176. Thumbs up who agrees with Macy.
Am I wrong?
Your number is absolutely perfect, Macy. There is nothing wrong with 176. You just didn't add enough to it. When it's area, what do we know about the unit? Do you remember? Kylie, do you remember?
Squared unit.
Yeah, it has to be units squared.
Oh, yeah.
So, this is 176 units squared. Everybody with me there? Hey, Macy, can I pick on you a little bit more?
Sure.
Can you redeem yourself for the second one?
Yeah, it'd be 55 units squared.
Beautiful. Okay, so individually, we can find those, right? If I gave you this rectangle and said find the area, if I gave you this rectangle and said find the area. Well, when we're dealing with a rectangular array, it's the same thing. So on your lines, you should have 176 units squared, and on this line, we should have 55 units squared. Why? Because we did 11 multiplied by 16. We did 11 multiplied by positive 5. But I don't want to stop there. Can I simplify this distributive problem? Can I simplify this? Because do we have a big rectangle? What would be the total area for this rectangle? So talk it over. Figure out how you're going to get the total area for the rectangle. Liam, you're the man. Tell me, what am I going to have to do to find the total?
You're going to add 176 units squared plus 55 units squared.
Good. So that gives me 1, carry 1, 12, 13, 13, 1. So that gives me 231. Is that right?
No.
Unit square.
Macy, is this right, 231?
No,
Why not?
because it has to have unit squared.
Good. This is how we're using a rectangular array to find an answer to a distributive problem. Questions on these? Okay, flip to exercise 3 on, I don't know, the back of the next page. It starts off with find the equivalent expression. And then there's 5 and 8x plus 3. So flip that again. Okay, is everybody with me? It says example 3. Okay, it doesn't say exercise, it says example 3. Everybody there? Okay, so what I want you to do is draw a rectangular array and find the simplified version. Go. I'm going to pull it up on the screen. So you guys can talk, because once you have your answer, I want you to talk it over with the people around you. See if you guys have the same thing and what you guys need to do differently if you don't. Okay, you got to simplify, you got to keep going. So we're setting up the rectangular array, but then the whole purpose is to multiply. This is just giving you a different look of multiplication. Okay, so this time it's not asking us to find the area. It's just trying to find an equivalent expression to this. We know equivalent means what? We did equivalent that very first day. What does equivalent mean? Go ahead, go back to your first packet. So lesson 1, go to the second to last page where it has all of that ready-made information. It actually has definitions for you from lesson 1. So if you go to lesson 1, I'm going to steal Izzy's here. I flip it to the last page. There it says relevant vocabulary. I don't know if equivalent's on there or not, but I'd take a look and see if we can find it. So I'm pretty sure it says equivalent expressions on those relevant vocabulary. Because if you weren't here for lesson 1, there's a folder with your name, or there's a folder that says hour 3 with your name on it with a sheet. Kylie, what's an equivalent expression?
Two expressions that way.
What should I? You let me know when to let go.
Okay, so two expressions are equivalent if both expressions evaluate to the same number.
Good. So, if I have 5 multiplied by the quantity of 8x plus 3, we're going to come up with another answer. As long as they have the same answer and look different, they are equivalent. So, tell me what I'm going to do. Now, I want to make a rectangular array. So what do I need to start doing first? Okay. I'm good with that. I'm a math teacher. Split it down? By here? Here? Where? Over here.
No, asking in the.
Oh, in the rectangle. Okay, go ahead.
Draw 5 on
Oh man, how do I draw it? Let's see.
That works.
Boom. That's a really pretty 5. I drew that really nicely. Okay? Go ahead.
Alright, now draw an 8.
I'm not going to draw it, but so you want me to write 8x?
Yeah.
Okay. Go ahead.
I'll draw a 3 and this jump.
Not just the 3,
Um,
but I want that positive 3. Okay, so this is a rectangular array, but we're not done. Because this is showing us the distributive property. Cole, what would go on this line in that first rectangle? Okay, it would be multiplication, so what would I get when I multiply? 40x, very good. So this box right here is 40x's. What would go on the second line, Braden? What kind of 15? Positive 15. So now it asks me to write an equivalent expression. We've used this rectangular array in order to write the equivalent expression, which is 40x plus 15. This is the same as this, even though they look different. We call those equivalent expressions. Questions on that? Okay, this is all we're doing today, is distributing using a rectangular array. You're probably like, this is really easy. Correct. You know why? Because we've already done it. So, homework. You're going to go to that problem set. You are only doing two numbers. You are going to do number 4. So go to that second to last page. Or actually, it's on the very back. It's on the very back. You're doing number 4. Now listen. You are doing A, B, C, D, E, and F. But it has very specific directions. Draw an array and simplify. Which example should you use? The one we just did. From exercise 3 or example 3 or whatever that was. Everybody with me? That's one problem you're doing. The other problem is number 5, all parts. This is just combining like terms. Correct. Now, here's my question to you. Should you do the work on this paper?
No.
No, you should be getting out a separate piece of paper because this is the stuff that you will be turning in. Everybody with me? And you've got about 6 minutes that you should be able to knock this out. So this was lesson 3 from module 3 for 7th grade from Engage, New York. Shoot. Questions? Great job today.